as previously discussed, that I'm going to teach neural network and learning machines. And today's session is on introductory session on what are the fundamentals of neural network. Now, let me move to my whiteboard. So, what is neural network? Neural network is a massively parallel distributed computing. So, what is neural network? Neural network is a massively parallel distributed processor made up of simple processing unit that has natural propensity for storing experimental knowledge and making it available for use. It resembles human brain into two aspects. Number one, knowledge acquired by the network. Knowledge acquired by the network from its environment to learning process. Through learning process. Number two, interneuron connection strengths, which is known as synaptic weights, are used to store the acquired knowledge. This is the fundamental definition of neural network. So what we have learned, that neural network is a massively parallel distributed process which is made up of simple processing unit that has natural propensity for storing experimental knowledge and making it available for use. And what it resembles? It resembles the human brain into two aspects. That is, the knowledge acquired by the network from its environment through learning process, interneuron connection strengths known as synaptic weights are used to store the acquired knowledge. Now, this is the two important points that you have to keep in your mind. What does it does? What it does? It resembles a human brain. It's like when you are in the childhood stage, when you were a child, we used to learn by looking at our environment. Okay, I hope you have observed a little kid learning through this process. The first what little kid learns, he learns who is his mom, who is his father, but by which input. His mom used to tell him, tell me mama, or his father or her father used to tell, hey, I am your papa, like this. And that mummy and papa keeps stays in that child's brain and starts learning as well. Okay, and after certain days, the child calls, looking at her mom, say, "Mama," and this is the first word. This is the first word. Now, in similar manner, neural network works. Now, the process and the procedure used to perform the learning process is known as learning algorithm. But in computer science terminology, when we want to train a kid, when we want to train a kid through and this machine learns through certain algorithms, and these algorithms are called a learning algorithm. The function of which is used to modify the synaptic weight of the network in an orderly fashion to attain desired design objective. So in machine learning or in computer science terminology, those who are working on computer science and machine learning, deep learning, the first step is learning. Okay, is to modify the modification of the semantic weight. Now, the modification of synaptic weights, this modification provides a traditional method for designing of neural network. And such an approach is closest to linear adaptive filter theory. Now, what is such approach is? Such approach is quite similar to linear adaptive filter theory. That is linear adaptive filter theory. Okay, now and this adaptive filter theory, those who have done their graduation BTech in electronics and communication engineering, they have some adaptive control system. They have some ideas on adaptive control system and all. That it really resembles this concept. Okay, now this adaptive linear filter theory is well established and successfully applied in many diverse and it has been proposed by Woodrow and Sturz in 1985 and some research papers I'm mentioning. However, it is also possible for neural network to modify its own topology, which is modified by the fact that neurons in human brain can die and new synaptic connections can grow. Now, what I have mentioned that that neurons in human brain in human brain can die and new synaptic and new synaptic connections can grow. What I mean by this, suppose some basic neurons, if I consider, suppose when you are in suppose you are in class 7 or 8 and you have the knowledge, you have studied history, geography and basic sciences. Now, as the day progresses, you can forget. Okay, but the basic things like I'm not considering the basic fundamental things like your name of your mom, dad, and address. That is already inbuilt. That you cannot forget. But as what happens when you started learning this topic and this terminologies, history, geography, you can might forget. Okay, so what you forget, that your that neurons that contain that information in class 8 of history, you can forget that. And new synaptic connections grow. That is the things that you are learning, constantly learning in your engineering days, that can grow. And this is the one of the advantage, or what can you say, disadvantage or advantage of neural network theory. That is, it it has been conceptualized that it nearly mimics the human brain. Okay, so what you have learned in the first part, you have discussed about what is neural network, and what it does is it resembles linear adaptive filter theory, and important terminology that neuron in human brain can die and new synaptic connections can grow, that I have explained. Okay, moving on to further, let me delete this and moving on to erase. Yeah, I've erased this. Now, what are the benefits? Now, when you are using a neural network concept in your machine learning, and what are the fundamental benefits that you can have? The first now that I'm going to discuss the topic benefits of neural network. Now, first benefit is non-linearity. Now, as it appears that neural network derives its computing power through first is massive parallel distributed computing structure, and second its ability to learn and therefore generalize. So, what does this generalization mean? Generalization. What does generalization mean? Generalization refers to neural networks production of reasonable output for input not encountered during training, that is during learning, and this into information processing capability make it possible for neural network to find a good approximation to complex solutions that are intractable, that are complex solutions, generalization of complex solutions that are intractable. Okay, intractable. Now, in practice, however, a neural network cannot provide the solution by working individually. Now, cannot neural network cannot provide solution by working individually. In practice, rather they need to be integrated with consistent system engineering approach. Now, in the computer science terminology, but it cannot provide solution working individually. We have to integrate into a consistent system engineering approach. So specifically, a complex problem of interest is decomposed into number of relatively simple tasks. Okay, and neural network are assigned as a subset of the tasks that match their inherent capabilities. To match inherent capabilities. Okay, match the inherent capabilities. So it is important to recognize, however, we have a long way to go if ever before we can build a computer architecture that actually that mimics the human brain. So what are the important properties? What are the important properties and capabilities of neural network? Important properties and capabilities of neural network. Now, first is non-linearity. Highly non-linearity. Number one, non-linearity. Non-linearity. Okay. What does it mean? An artificial network can be linear or non-linear. That will can be linear or non-linear. That we'll see in the subsequent lectures that are going to come. A neural network is made up of interconnection of neurons, and it is itself a non-linear. Moreover, non-linearity is of a special kind in sense that it is distributed throughout the network. Now, non-linearity is an important property, particularly if the underlying physical mechanism responsible for generation of the input signal, that is speech signal, is inherently non-linear. Our speech signal is inherently non-linear. Second point is input-output mapping. Now, what is output mapping? Input-output mapping is a popular paradigm of learning called learning with a teacher. Okay, which involves or supervised learning. Generally, computer science, those who are in computer science background, those who are in working in machine learning and deep learning, they are quite familiar with the term supervised learning, and it involves modification of synaptic weights of a neural or network by applying a set of level training example or task example. Each example consists of unique input signal and corresponding desired target signal. Okay, target response. The network is presented with an example picked at a random from a set, and the synaptic weight, that is the pre-parameter of the network, are modified to minimize the difference between the desired response and the actual response of the network produced by input signal in accordance with an appropriate statistical criterion. In an appropriate statistical criterion. Okay. Now, the training of the network is repeated for many examples in the set until the network reaches a steady state where there are no further significant change in the synaptic weight. Now, let me discuss this with an example. Now, when you have started learning in your childhood, uh, first observation, your mom and dad used to ask, they guide you. Look, this is chair, this is bed, and this is. Now, as the continuously you are going to learn from your parents, this is the supervision. Your parents are supervising you to learn from the physical experience or physical knowledge or physical thing that you can see in your environment. Okay, so in a similar fashion, neural network works. Previously applied training examples are reapplied during the training session. Now, what does this mean? This means that when you have when you have started learning. Now, when you see a chair in your room, for example, a chair in your room, a chair in your room. Sorry, I made a typing error. A chair in your room. When you were a child, okay, you say a chair. Now you have made a assumption like, no, chair has 4 legs. You were only a single person can sit, and that you are continuously seeing that. And when you move out and when you move out and see and when you move out to some other places, to your friend's house or yeah, now when you see such a similar thing, nearly similar thing, like it has 4 legs, where you have only one person you can where can sit there, you can resemble, yeah, this is a chair. Okay, so this continuous training makes a neural network more efficient. Okay, it's a more precisely, you can say that it's a more repetitive reapply and repetitive training session. Okay, now thus the problem and had such as approach the network learns from example by constructing input-output mapping or the problem and such approach brings the mind of study of non-parametric statistical inference, which is a branch of statistics that deals with model estimation or, from a biological viewpoint, tabula rasa learning. Now let me type it for you. It's a tabula rasa training. It's a statistical non-parametric statistical inference. Okay, which is a branch of statistics deals with what does it deals with? Model free estimation or from biological point of view, we can say tabula rasa learning. Okay, it's from a German et al. Research paper I have referred, and the term non-parametric is used here to signify the fact that no prior assumptions are made on a statistical model for input data. Now, when when you are a child, and you have something, you have started learning, you don't have any statistical inference in your mind. What things you learn? You learn from your mom and dad and your friends or any uncle, auntie, etc. So, from the biological point of view, it's a model free estimation. You cannot estimate. Okay, so this is the input output mapping. For example, pattern classification tasks which require an assignment of input signal present represent a physical object or event to one of the several pre-specified categories or classes. So this is a common thing. All the deep learning and machine learning engineers generally perform the pattern classification task. Okay, as a common task in machine learning algorithm. Third is adaptivity. Third is adaptivity. Let me forward delete this. Now three is adaptivity. What is adaptivity means? Neural networks have a built-in capability to adapt their synaptic way to change in the surrounding environment. What does this signify? Which signifies that, for a real life example that I'm going to take is when you have seen a chair in your room, okay, and when you go out and you find a similar kind of object is there, you have the back of the mind, it runs that, yeah, this is a chair, this is a chair. Okay, you add up with that, but maybe the design or the shape of the chair does not look similar, but you have something in your mind that, yeah, in a chair has four legs, what one people can see. So in this way, neural networks has an inbuilt capability to adapt themselves in the surrounding. In particular, neural network is trained to operate in a specific environment, can be easily retrained to deal with minor changes in the operating environment conditions. This is the thing I have just explained. Moreover, when it is operating in a non-stationary environment, that is where statistical changes with time, neural network may be designed to change its synaptic weights. Okay, in real time. This is also the example of chair that I have given. Okay, chair example, child, child chair learning. Okay, chair description learning. Okay, learning. Now, in the natural architecture of neural network or pattern classification, signal processing, and control after coupled with adaptive capability of network makes it a useful tool in adaptive pattern classification, adaptive signal processing, and for electronics and electrical engineering department students, it's on adaptive control. Okay. And then in general rule, we can say that the more adaptive we make a system, all the time, ensuring the system remains stable. Okay. The more robust its performance will likely to when the system is required to operate in non-stationary environment. Like something I must say that whenever you have seen like this kind of example, when you're a child and when you have seen lot of chairs, okay, and when you go into a marriage ceremony, suppose you as a kid you have been taken to a marriage ceremony, there were a lot of chairs. Okay, lot of seating arrangements is that, yeah, you as a child, you yeah, this is a chair, and you don't get confused because you have been trained in several times, you have seen chairs in several times at your home. So this is the way, this is the when such a trading has been made, you don't make a mistake. Okay, this is a chair, this is not a bed. And by going to a marriage center, when you don't go and suddenly fall down in a chair and start sleeping. No, you don't. You have that knowledge after such a lot of training. You have a knowledge that this is a chair. This is the concept of adaptivity. Now moving on to the fourth point, evidential response. Number four, it's evidential response. What is evidential in context of pattern classification? Okay, a neural network can be designed to provide information not about which is particularly pattern to select, but about the confidence in the decision rule. Now, this is also the example that I have given chair case. This latter information is very useful to reject ambiguous pattern. Suppose
ambiguous patterns. Like, give me an example to you. Suppose you went to marriage ceremony, and you have seen that during marriage ceremony, some two double chairs are been kept for a bride and groom, and we have been for the invited persons, so they have kept the single chair. Okay, you don't make that such kind of mistakes. Yeah, it's a bit single chair, it's a type of chair, but this single chair is for double chair is for bride and groom, and this single chair for such evidential response will be there. Now contextual, fourth point is contextual information. Contextual information. The knowledge is represented by a very structured and activation state of neural network, and every neuron in the network is potentially affected by the global activity of other neurons in the network. Consequently, contextual information deal with naturally by neural network. Okay. Now, sixth point is fault tolerance. Fault tolerance. Suppose, for example, fault tolerance. Let me give you an example of a chair example. Maybe you can make mistake, or by daily go and sit into bride and groom chair. Okay, you can make mistake, but after you visit after visiting 2 to 3 more such kind of marriage ceremony, you don't make such mistake. Because your neurons are continuously trained in your brain, getting trained. Yeah, after in the first maybe you have make a mistake in when you have visit, maybe you might not remember, or maybe you remember some funny moments when you first went to a marriage ceremony and went on and sitting on a bride and groom chair. Maybe they are highly decorated that attracted your eyes, but so your mom has scolded you, or father has scolded you. It may be such kind of funny moments that could have happened in your childhood days. But after visiting 2 to 3 marriage ceremonies, and now you have after in the younger age, elder age, when you went over there, and you don't make such mistake because your brain has got trained. Yeah, this such kind of in a marriage ceremony, decorated chairs are for bride and groom, and single seated chairs are for invite. Okay? So this makes a neural network fault tolerant. Fault tolerant. Okay. Sixth point is VLSI, implementability. Okay. What does it mean? The massive parallel nature of the neural network makes its potential fast for computation of certain tasks. And same features makes a neural network well suited for using VLSI. Okay, VLSI technology. One particular beneficial virtue of VLSI that it provides a means of capturing truly complex behavior in a highly hierarchical fashion. In a new highly hierarchical fashion. Okay. So, next point is chapter point 8. It's point 8 is uniformity of analyzing and design. Uniformity of analysis and design. Okay. Now, by basically neural network enjoys a university of information processing. Now, what does it mean? Suppose when you are going to train a chair in your mind, when you went to a marriage ceremony and you want to sit in a chair, but after you are not there, marriage, you haven't went there for sleeping. Okay, you don't search for kind of bed, or you search for a chair where you can sit and see the rituals that has been performed in a marriage setup. Okay. It's a uniformity of analysis. It means what are the uniform thing you want to analyze? If you want to analyze a chair, you have to find a chair. You just analyze the chairs. Okay, like looking at the sitting chair for the invited persons, invitees, and similarly for essential chair analysis for the bridegroom chair. And neurons in one or other form represent an ingredient common to all networks. And modular network can be built to seamless integration of modules, and in real time also you can, when you can train multiple times of multiple images in a real time, where you have the variety of knowledge, a variety of design of chairs of, but the basic things it's highly informative, because when you are analyzing for a chair, you don't general case you don't analyze for a bed, okay, or and case you doesn't. Now you have to search for bed and chair. Suppose you don't do that. You do, in a general room, when you want to sit, you don't search for a bed. When you want to sleep, you don't search for a chair. Okay, so such thing can happen. Now fourth point is number 9 point is neurobiological analogy, and it's neurobiological analogy. What is it, neurobiological analogy? Now, when you are trying to analyze a neural network algorithms or architecture, you generally one of the first thing come into your mind, neuro. The word is neuro. That is derived from the word neurons. Then you strike in something, strike in a, yeah, this is the thing I applied in our school days. This is how this neuron works, how this neural signal can connect this. Okay, in this analogy makes this algorithm quite easier for you to learn and analyze the subject very properly. So these are the benefits of neural network. These are the advantages, and what can you say? These are the properties and the capabilities of neural network that is being used. Okay, that you can use in your real life in your machine learning approach. Moving on to further, should I do basically should I try analog and some few concepts of block diagram of a nervous system, because I'm not going to deep into the human brain. Okay, it's a biology chapter. You can all we know, because we have all learned in our BTech school days what is the human brain, what is the structure of human brain. So, but in present scenario, I just want to have some block diagram representation of nervous system. Okay, where we can find an analogy of how this neural network works. Okay, let me delete this. So the headings of the topic I am giving is block diagram of nervous system. Okay, nervous system. Now in block diagram, what are the first part? First part is stimulus. Stimulus is the thing that what can you say, that increase your quest for the knowledge. Okay, quest for the thing. Okay. Then we have stimulus, then you have receptors. What is the work of the receptors? The receptors receive the stimulus and process and multiple parallel processing of human brain through a large set of neural networks, that neural nets that processes in your brain, and correspondingly after processing it produce an effects that is known as effectors, and it give us the desired response. Yeah, the thing is that you see a chair. Okay, your eyes fall into a chair. You see a chair. Okay, you see a chair. That is the stimulus, and that this is the shape of the chair. Increases the adrenal rush in your brain. Yeah, this might be this is a 4-leg single seated. This might be. Now in the neural net processing in your brain is going to, yeah, I have seen such kind of thing. Now in the after making such a response, these are the effectors, and after the effectors is the positive response. Yeah, this is a single seated 4-leg object. This is a chair. Okay, then you go go and sit into a chair. Okay, that is the response. So this is a block diagram of a nervous system that generally works in this flow chart. You can say that this works in your brain. Okay. So I'm not going into details of structure or the levels of brain, human brain, that you can generally find in any of the biology books of human brain. You can see the actual structure of human neuron. That is least interested. Okay. Now moving on to further, moving on to the matter of interest of us. Okay, that is the matter of interest, that is how the neural network, that is the block diagram of neural network look like. How does the block diagram of neural network look types that you apply human brain in computer computation in computer computational procedure. Okay, so uh, let me erase this. Yes. Now, how does this human brain has nonlinear model of neuron look actually a simplified mathematical model of neuron maybe look like to you and for your computation computer science purpose for their application purpose. Okay, so now what is the actual what is the neuron of interest that we generally use in our computer science, that in machine learning and neural basic neural architecture. Okay? So first, the basic fundamental block diagram look like this. Mhm. Fundamental block diagram look like this. It has got a set of synapses, that is set of input like this, like this. These are called x1, x2, x3. Like these are the corresponding weights as well the corresponding input signal, and the corresponding weight has been assigned. That this thing I'm going to I will go in details, and after that there is a bias input here. Let me draw again. This is the thing happens. So when you use this kind of writing examples, okay, these are the inputs, corresponding inputs, wx1, x2, x3, and corresponding weight associated. I will discuss what is the weight associated with this, and this other. And there is a bias term, and you have the bias term, and we have an activation function, block diagram. Yes. And we have our desired output. We have a desired output. Okay. So what does this mean? What does this mean? Now, what are synapses? Synapses are the connecting links of each of which characterized by the strengths of its own. Specifically, a signal X at the input of the synapse is connected to the neuron is multiplied by the synaptic wave. It is important to make note that of the manner in which the subscription of the synaptic waves are written. The first WKJ refers to this W. These synaptic weights are referred to WKJ. Please try to cope up with this. Text W space KJ. Okay. And it is important to make that the weight are associated in refer to neuron in quotient, and second subscript refer to the input end of the synapse, and with the weight refers to. Now adder for summation, we are taking this example of x1, this x1, this x1, x2, x3, like this. These are the corresponding weight, these are the corresponding input. Like suppose you have seen a chair, 4-leg chair with a wonderful design like this. Okay, a simple 4-leg chair, like sitting table chair like this. and a simple design and decorative chair like this is the corresponding weights. Okay, that is the thing that stuck in your mind. Okay, let me draw it again. Let me draw it again. Uh, okay, these are the summing junction. These are the corresponding input synapses. These are the weight functions, and these are the corresponding x1 input, x2 input, x1, x2, x3. This is a connection to the activation function, and this is your output. And this is there is a bias term. What is that? Yeah, these are the corresponding bias term. These are the corresponding bias term. And this is the thing I'm going to explain in detail. So activation function is for limiting the amplitude. It is a function of activation function is used for limiting the amplitude of the output of the neuron. The activation function is referred as squashing function. That is that it squashes the limit the permission amplitude range. Okay, I'll discuss in detail the activation function. There will be a separate topic on that. Okay. Now, as you have seen that in the previous thing that this activation function, this neuron looks like this. Okay. This neuron, structure of neuron look like this. Here is the activation function. What does the activation function does? Okay, as in human brain, we cannot see the activation function, but there is a certain limiting value thing. But when we are doing mathematics and like mathematically implementing such neural network, you have to take care of this activation. What does this activation function does? The activation function provides certain limits, okay, certain limiting function that helps the algorithm to don't go out beyond such limit. Okay, so in mathematical terms we may discuss this structure of neuron into some mathematical formulas. So what you can discuss that in mathematical formulas we can write in this way wk. In mathematical term we can write it as output. If you define output as output of the summing junction as u, okay, is equal to summation of of x input x1 input and w jk kj or jk kj. Okay, sum of this input and output activation input unit and some activation input unit and synaptic weight. Now what is the corresponding output will be? If we define output, this output, here is the output will be, oh my God, this eraser, let me use this. Okay, now we can define the output as like this. Next, if you define u as a summation and corresponding output will be op will be let us define the output as y. So y will be some activation function, like suppose that let me define it as f, the activation function, and it's a summation of input, that is u, plus 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 b. Okay, what does this b mean? This b is the bias term. This b defined stands for b is bias term.
bias term. So this is the fundamental structure model of a neuron, and is as a first part we are going to deal with this simple functions. Okay. Now moving on to further. Now moving on to further. Uh, Now moving into further, if we had added a bias term as an external parameter of the neuron, we may account it for its presence. Because what is the requirement for a bias term? Why do we require? What is the need for a bias term? The need for the bias term is due to the fact it's because suppose we have multiple kind of options. Suppose some kind of when you learn training a machine, yeah, you want to yeah, I have to look for change. Okay, this is a bias. This is the time. But you have multiple things around. Okay, so if you add a bias term, so you just have that in a bias term formula, you have four legs. Okay, oh, single seater. Single seater like this. Okay, this is the bias term. This is the bias term. This is my bias term. Okay, this is my bias term. Now moving on to further, and so does when and fixed input for a fixed thing, fixed if you fix this chair. Okay, if you fix this chair for example, so we have that summing junction, you have input bias term. Okay, so this is the first part of basic function. How does basic neuron look like? Yeah, I'm extremely sorry that this first part I'm just doing this, or my pen is not working properly, but I'm trying to explain. Now moving on to further types of activation function. I have told you that activation function plays a major role. Types of activation function. So activation function plays a major role in neural network analysis. So what does this activation function does? The activation function does not allow the neural trailing neuron to get out of certain bound. So if zero, if your mm, if your condition, if your object does not fall into the four legs and single seater, it gives you zero. And if it gives a more than that, if the function matches, then if you give you one. So there are various types of activation function. The commonly used activation function is threshold function. Threshold function, and for this type of activation function is described as f of x equals to 1 if x is greater than equal to 0, f is equal to 0 if v is less than 0. Now this is an important function. So basically in engineering form of a threshold function is commonly known as, is also known as heavy Heaviside function. It's also known as Heaviside function. It's also known as Heaviside, types Heaviside function. And corresponding output can be expressed as y equal to 1 if if activation function, if the activity vk is v is greater than equal to, it's greater than equal to 0, it's sorry. Sorry, I made a mistake. Here it will be x is less than 0. X is less than 0. If x is greater than 0, or if x less than 0. So and a neuron, local neuron, and output will be output VK. Use if VK is induced, that is in the local field of neuron. The output that is xk. X will be output x in the k domain will be represented as summation of xi vk, that is x equal to summations of all the weights product of summation of all the weights, that is defined as w, into input of all the input plus the bias term, and the corresponding output corresponding images, corresponding function look like. How does this corresponding function, Heaviside function, looks like? Let me show you. This Heaviside function is a simple function. It generally looks like this is for 1, this is for 1, and this is for 0. Okay, and it is continuously increasing, maybe increasing or constantly decreasing in this pathway. Okay, so in this way this heavy activation, this activation function looks like. Now moving on to further, second type of activation function that is most commonly used is sigmoid function. Sigmoid function.
Sigmoid function. Sigmoid function whose graph is a S-shaped curve, S-shaped curve is by far most common form of activation function used in construction of neural network. It is defined as a strictly increasing function that exhibits a graceful balance between linear and non-linear behavior. So it's an important point. Why a sigmoid curve is generally preferred? Why sigmoid curve is a function is generally preferred as an activation function? As it's a strictly increasing function, that exhibits a graceful balance between linear and non-linear behavior, and it's generally expressed as f of x is equals to 1 divided by 1 plus
exponential of minus a x,
where a is the where
a is the slope parameter,
okay of the sigmoid function
of the
sigmoid
function. Okay.
By varying the parameter a, we can obtain sigmoid function of different slopes. In fact, the slope at the origin equals to a by 4, and in the limit as a slope parameter approach infinity, the sigmoid function simply becomes a threshold function. So, as slope reaches infinity, sorry, infinity,
it becomes becomes a threshold function. So this is the shape of the. These are the most two important topics, important things,
two important common activation function to generally use while doing neural network strategies in machine learning. So these are the things. Now moving on to the further, how can you define it in such a way if we want to express in a range from 0 to 1? So how can we express that? We can express as we can write this as a phi of x, that is mm, y. Suppose let me define this with y of x is equals to 1 if x is greater than 0, equals to 0 if x equals to 0, equals to minus 1 if v less than 0. So in this way, these are the and which is and this is commonly known as signum function. We are generally known this is a signum function, and sometimes this sigma function is also sometimes hyperbolic tangent function. We generally know this. So we can use different kind of activation function for general purpose of use of in neural network application. Okay, so this is a thing I might discuss. I have discussed with you the what are the important types of activation functions generally being used in designing neural network. So uh, let me end today after this, and in next lecture we'll go for stochastic model of neuron, and after that how neural network can be viewed, that is directed graph. Okay. Thanks for your time, and I hope this lectures find you some of the important, beautiful insight of how the lectures is going to be. So, idea there might be some uh, uh, error in the error while presentation because this is my first video lecture, and I'm just trying to learn how to use uh, pen, digital pen, and all these things. So there is might be some you can find in the lecture. So moving I can tell that if you go to each and every word of this video, I think you will find very fruitful knowledge in the coming lectures to come. And in the next lectures, I am going to discuss stochastic model of neural network as a directed graph, then neural network as a directed graph, and some feedback concept of feedback will be there. Then I will give a brief overview of various network architecture that will be beneficial for uh, deep learning researchers and neural network machine learning researchers, like a single layer feed forward, multi-layer feed forward network. recurrent breathwork, and etc. Okay, so I'm going to end my lecture right now. Thanks for your cooperation, and your review is highly beneficial for me. Please review, please listen to the lectures, and please put a review so that I can edit and edit and in front of you. Thank you for your time.